Today, I will be discussing more on some big expression, handling big expressions in mathematics using LaTeX. Now, remember that our syllabus contains a lot of things other than the mathematical expressions. In the previous class, I tried to introduce you how to write equations, how to put references, and so on. Okay. Now, I also want to introduce you how to insert a table. Okay. So, how to tell a LaTeX that a table is to be started? From the previous class, it should be clear that we have to tell the LaTeX that you should begin a table and end a table. So our command will look like /begin table and /end table. Now inside the table, what is there is that a tabular arrangement. Okay, so let us see how it comes. So I have a shortcut, so I will make it very fast. So I already told you how to start a table. So you can see that there are only two commands, begin table and end table. So with this, LaTeX identifies that a table is here. Okay. Then the next command is begin tabular and end tabular. So you can see that there is a LCR option. I will tell about it later. Now what is that? Yes, this means that there are three columns in this table. Okay. And the first column is left aligned. The second column is center aligned and the third column is right aligned. Okay. Now let us type something. That is, I can type 1, and in order to move to the second column, I need to put a and. Okay. Now I can type 2, right? And I already told you that there are three columns. So I need one more column. So in order to move to the next column, I need to put an and. Now you can also insert some mathematical symbols. So for example, if I put $, I'm going to tell the LaTeX that some mathematical expression is going to insert there. So after $, you can type, for example, 2 square. So it is 2 raised to 2. Now I have completed all three columns of my table. Now if I need one more line, I need to put a double slash. This is how we can go to the next line. Now let us continue. Say 3 and 5. Okay, 7. Now if I run this, you can see that there will be a table with columns, 3 columns. The first column is left aligned, second column is center aligned, third column is right aligned. So I'm going to run with a shortcut button. So you can see the output there. So you can see that 1, 2, 2 square, 3, 5, 7 are there. But it doesn't look like a table, right? Because in your mind, a table contains some cells. Okay. So in order to bring or introduce cells, or in order to introduce some column, line separating columns, you can add the corresponding keys from your keyboard, that is vertical lines. So this means that the first column and the second column are separated by a vertical line, and the second column and third column are separated by a third, and also at the end there is a vertical line, also in the end there is a vertical line. Now let us continue. So you can see that 3 columns are separated by vertical lines. So this is left aligned, center aligned, and right aligned. Now how to insert horizontal lines? So for horizontal line, for example, just above the first row, you just need to add /h line. So h line brings you a horizontal line. Now in order to add a horizontal line as the last line, so you are adding a horizontal line as a last line, so you need to go to next line by putting a double slash and then add /h line. Remember that this is a programming language. It doesn't matter where you are writing the commands. So you can either write H line here, or you can insert your H line here. Okay, anywhere. So you can see that there is a horizontal line in the beginning, a horizontal line in the last. In order to put a horizontal line in between, where you should put that? Okay, you can see that you can put it as a second line, right? Now, how to go to more mathematical concepts. Now I will start with writing, introducing a matrix. Now a matrix contains, yes, some elements, some especially some mathematical expressions arranged in some order. Okay, in some m by n order. So how to insert a matrix? So before that, I will introduce how to introduce an array. So in order to start an array, I will write begin array, end array option. So an array means an arrangement of something. So you need to tell your LaTeX that how many columns will be there. For example, here I am going to put CCC. So what is the meaning of that? This means that this array will contain 3 columns and each column is center aligned. Okay. Now I am going to put some values, for example 1 and 2 and 3. Now also in the next line, some 4, 5, 6. So here some 4 and 5 and 6. Now I am going to write a matrix containing the values 1, 2, 3 and 4, 5, 6. But if you check this, you can see that I have only 1, 2, 3 and 4, 5, 6 available. So I need to put a bracket in the starting and also in the ending. Now how to do that? So in order to start a one thing I forgot, that this is a matrix is a mathematical expression. So you need to tell the LaTeX that you are going to enter a mathematical expression. So how to do that? By putting a $sign in the starting and ending. So now the entire thing is a mathematical expression. Okay. Now we need a bracket. So we need a square bracket in the starting. So I put a square bracket in the starting. So after the square bracket, the entire arrangement is here. And after that, there is an ending square bracket, right? Now, if I do this, we can face another problem. Let us see the output first. What is the problem? The problem is that the left bracket actually does not contain the matrix 1, 2, 3, 4, 5, 6, or the right bracket also not sufficiently large. Now we have to tell the LaTeX that this left bracket is not only an ordinary left bracket, or not a ordinary left bracket. This actually contains something. Okay, so this is the left of something and this is the right of something. Okay, some mathematical expression. So in order to do that, I need to tell LaTeX that this is a bracket which is the left of something. So I am going to type it as /left. Okay, and here the closing bracket is the right of something. So I'm going to say that /right bracket. Now we will be having a matrix with a closing bracket square and 1, 2, 3, 4, 5, 6 inside. So you can see that now the closing brackets are sufficiently large to contain the content of your matrix. Now how to put A is equal to, so you can see that this is the entire matrix you have. The first and last dollar symbol says that this is a mathematical expression, and from left bracket to right bracket gives you the entire matrix. Now how to put some matrix A is equal to 1, 2, 3, 4, 5, 6. For that you can put A is equal to, where you can type A, you can type it anywhere in between the dollar and the slash sign. So for example, I can write it as A is equal to here. Now the matrix will look like A is equal to 1, 2, 3, 4, 5. Okay. Now in order to add another column, we just need to introduce another column. You just need to specify that another column environment is there. For example, you can put an R. So you can add one more column. Or in order to put a new row, you can put a / and say 7 and 8 and 9. So once again, let us go to the output. Now we can see that we actually wrote the table and the LaTeX. Okay. I actually inserted the matrix command before the table command entered, so I am putting it separately. Okay. Now let us compare the table and the array. What is the difference between table and array? The array usually assumes that some arrangement is there, and usually we use it for the mathematical expressions. In the case of tabular, you can have mathematical expressions and also text in as the elements for a tabular arrangement. Now the additional thing in a table is that you can actually put a caption in your table, and also you can put a label. So okay, so I will show how to put a caption in a table. So in order to put a caption, we already saw the similar thing while inserting a figure in a LaTeX. So how to put a caption? You need to tell the LaTeX that /caption. Okay, this is some table, and you can also put a label for that, a label, so that you can refer this table somewhere else. Okay. So for example, tab1, you can put whatever be the label, you can call it later. Now what you can see is that there is a table, and this is some table is the caption. There will be the caption for that table. Let us see that. This is some table. So you can see that this table is actually moved to the top of your page. So I always tell that these table figures are all everything are floating environments. So yeah, LaTeX suitably finds a position usually in the beginning or the end of the usually it moves the table or figure to the starting or ending of your page. So you can see that the table is moved to the top of your page. So how to place it on position? So you have to tell the LaTeX that yes, you need your table here itself. So I am going to put an H here. Okay. So you are going to tell the LaTeX that you need your table here itself. So H is an optional argument you can place. And also you can see that this table is not centrally aligned. So to put a table centrally aligned, you can put /centering. Okay. So now you can see that once the table environment is there, you can see the corresponding table which is centrally aligned with the caption. This is some table. Okay. Now I am going to move to more mathematical expressions. So inserting a new section. First thing is that how to insert a Greek letter in LaTeX. So in order to introduce or insert a Greek letter, you just need to know the spelling of that. For example, $. In between the dollars symbols, I put /alpha. That is, it is going to be the Greek letter alpha /beta or /gamma and so on. So if I put some cap 3, this is going to be alpha, beta, gamma, Q. Right. So alpha, beta, gamma can be, or whatever be the Greek letter. So if I put some delta /delta, other than starting with changing its first letter to capital D, you can see that capital delta is obtained. Okay. Yes. So this is capital delta. Now next thing, how to introduce a fraction. In order to introduce a fraction, I need to have fraction command, that is /frac. Okay. Other than calling it as a fraction command, you call it /frac. Okay, frac command. So for a frac command, there are two arguments, one for the numerator and one for the denominator. So if I put 1 and for as the first argument and 2 as the second argument, you can see that 1/2 is placed in the corresponding position. Now I will show you that 1/2 is placed. Now I am going to define dy by dx is equal to, so what is the definition? Limit delta x tending to 0 as f of x plus d by dx of f dash, that is f of x plus delta x minus f of x by delta x. Okay, so let us write that. So I am going to show you the corresponding command first. We know how to insert a fraction, so you need a slash frc command and write this in the numerator and write this in the denominator. Okay, now here you need capital delta, so you know how to insert a capital delta. It's a Greek letter. Okay, now another thing in this definition or in this expression is that there is a limit in the starting. So this limit, I call this as a log-like function. Okay, so you can see that log or trigonometric or limit or some mode, etc., so on, are log-like functions. That is, we don't just type lim, we type it as slash lim. Or for example, in order to add sine theta, you add slash sine other than sin. Okay, so I'm going to insert this expression. So let me put $$ in order to say that this is some displayed formula, and I need to tell that limit delta x tending to 0. So it is limit. So you carefully watch how I am going to write it. Write it. Limit delta x tending to 0 should be in the suffix. Okay, so I put underscore. Since underscore is a command and we have an argument containing more than one letter, we need to put introduce curly brackets so that we can put delta x tending to 0, everything as underscore, sorry, after underscore, that is slash delta x tending to 0. So how to insert a tending arrow? So you can say that it is a right arrow, so I put it as slash right arrow. Okay, so right arrow 0. So far you have written limit and underscore means suffix delta x tending to 0. So let me show you the output. See, now I need to add a numerator and denominator. In the numerator I need something, okay, and denominator. Now how to insert a numerator and denominator? So you have slash frc command. So in the numerator you need to write f of x plus delta x minus f of x. So here I am going to write f of, okay, x plus slash delta x. Remember that you need to put a space after a command if another command is not following. For example, if you put a slash delta x, then you can see that this is not familiar command for LaTeX, so some error will appear. Now continuing, we have already typed f of x plus delta x minus f of x. Then in the denominator you need some delta x, so slash delta space x. Now once this is finished, we can see that our required expression is available here, right? Now let us go to another problem. How to type things like this? So okay, in order to add, we need summation. What is the command for summation? You can see that it is just a slash sum, and this should be in the underscore, and this should appear as the cap. Here int is the corresponding command for integration, and 0 should be added as the underscore or suffix, and the infinity is a new we need another command for infinity, then some fraction is here and dx. Okay, so let me type sigma is equal to 1 to n xi is equal to integral 0 to infinity 1 by x square dx. Now remember that LaTeX can transfer every formula into a single line. This is not difficult because this is how you can transfer one expression from one person to another, even using your code like that. So I'm going to write. So let us prepare with some double dollar symbol. So I need slash sum, and in the denominator I need I is equal to 1 to n. Okay, so denominator, so not denominator, sorry, as a suffix, so it is I is equal to 1 and cap n. Now you have summation underscore I is equal to 1 and cap n is ready. Now you need some xi. Okay, so we need x suffix I is equal to, you now need integration from 0 to infinity. So it is slash int underscore 0 and to infinity. So 2. So infinity contains more than one letter. So in order to add more than one letter or insert more than one letter, you need to introduce the brackets. If only single letter is there, you don't need a bracket. So here you don't need a bracket. Here you don't need a bracket. Here also, but here you need a bracket, right? Because there are more than one letter. Now infinity is slash infty. Okay, so now you have 1 by x square dx. So it is slash frac 1 by x square. So x square. Now dx should be there. So I put a slash space. Slash space is for just a space and dx. Now you have a double dollar in the starting, double dollar in the ending. So you can see that our output will be ready. Now if I show you the corresponding output, yes, corresponding command is ready. Now there is one more. How to do this? So instead of sigma, here it is capital U, sorry, union. So this is I can show you the corresponding commands. Big cup, right? So if I put big cap, it will be intersection 1 to n b0j, right? So this command comes from big cup. So if you put only cup, it will be a small union symbol. So in order to have a big union symbol, you need a big cup command. So see this, it is slash big cup. Okay, then underscore 1 means the 1 will appear as a suffix, cap n. Now correspondingly you can read it as a underscore I is equal to, now this is slash big cup again. If I put slash big cap, it will be intersection, then underscore 1 cap n, and here you need a underscore and cap. Okay, since there are only one letter, you don't need a bracket. So it is b, capital B underscore 0 and cap j. Okay, so the corresponding command is available here. Now we already saw the command. I have placed it here. Yes, we know how to introduce a matrix now. So you can see the corresponding output. So you just need a is equal to so slash left square bracket in the starting and a slash left slash right square bracket in the ending. Now can you do this problem? How to do this? So I will introduce some more symbols. So this will be a suffix 0 is equal to slash left square brackets, and here there will be slash right closing square bracket. Now in between this there should be an array. Now what is the dimension of this matrix? Okay, so it is not clear what is the dimension of this matrix, but we can say that this is just a 3 by 3 matrix according to LaTeX. Why? Because you can see that there are 3 elements in the first row, mainly 0, the center nodes 0, and 3 elements in the second row, mainly this is a vertical dots and this is diagonal dots, and this is again vertical dots. Then in the last row it is 0 C dots, that is center dots, and 0. Now if I type that, you can introduce such things very quickly. So I just need double dollar in the starting and ending. I'm going to type A is equal, I'm just going to read the matrix. So A is equal to slash left starting square bracket. So whenever I have something started, I need to stop. So slash right closing square bracket. So in between I need an array. So I introduce an array, right? So there is a begin array and an end array. Okay, let me put it in the second line in order to see it clearly. Now I need 3 columns. Okay, so I need to say the LaTeX that there are 3 columns CCC, all of them are central aligned. Then I need to write the first row. First row is 0. Moving to the second column using an AND. Then I need slash C dots. Sorry, C dots. So C dots is placed, and 0. So I have completed my first row. Now what is the second row? Let me check. Yes, it is V dots, diagonal dots, and V dots, vertical dots, diagonal dots, and vertical dots. So I need to write slash vertical dots. So V dots is the command, corresponding command, and slash D dots is the corresponding command, and slash V dots. Now I have one more row, or I can do the same thing, copy paste 0 and C dots and 0. Now this is the end of the array, so I don't need a double slash. Now you can see that in one single try I can complete the entire matrix, and if I run that, you can see, yes, our required expression is here. So you learned about C dots, D dots, okay, and V dots. Now this C dots actually center aligned dots. Now if you need, for example, low or aligned dots, you can put slash L dots. Okay. For example, if I need to type capital N is equal to set of natural numbers 1, 2, 3, etc. Okay. So I start with slash math bb capital N. So if I run that script, N is here, some error is there. Okay, just a second. I need to introduce AMS math, AMS theorem, etc. here. So I will skip that and put with the appropriate package. Yes, N is equal to, I need 1, 2, 3, etc. So if I put 1, 2, 3, etc. for etc. if I put L dots, you can see that this square bracket, sorry, this curly bracket will not appear in our output. Why? Because this curly bracket is assumed to be in use for the LaTeX commands to put their arguments. Okay. Now, in order to put a bracket here, you need to clearly say that this is the curly bracket. Okay. So for that, you need a slash curly bracket here and a slash closing curly bracket. So if I go to my last presentation, you can see that, yes, all these symbols are specially made for LaTeX on the left side. And in order to see, you can see that this slash, usually we need it for the to start a command, or curly brackets are for placing the argument. So in order to bring a slash, you need to clearly say that it is a backslash, or you need to type slash text backslash. So similarly, you need to, if you need to bring a curly bracket, you need a slash curly bracket and slash curly bracket closing. Now what is a percentage sign? I will show you. If I need to remove one command or hide one command or put as a comment put some comment, so I just need to start with a percentage sign. So if I put a percentage sign in Technic Center, you can see that there is some color change for that. So this is some, okay, these are some comments. If I put this, you can see that this will not appear in the output PDF because LaTeX identified this as a comment. Okay. Now similarly, tilde, I already mentioned tilde in the last class. This is a bond between, this is not only a space but a bond between the letters on its left and right. Now dollar, we already know the use of dollar, underscore, cap. So for everything, these are identified as the LaTeX, especially used in LaTeX commands. So you need additional commands to present those things. Now and, we are familiar with and now, which is used to separate the columns between columns in a table. Now hash is specially used in text commands. So usually we don't use in our LaTeX documents, other than in some when we have some correction needed in our packages or modification needed in our packages. Now let me go to another problem. How to insert it? I'm going to type the command, just explaining this. So this is an array, right, having 1 2 3 4 columns. You can see that this is clearly center aligned, this is left aligned, okay, this is also center aligned, and this is right aligned. Okay, and there's a comma 2,978 is here. Now it is very easy. So this is a 4-column array, and you can use and to separate the elements to different columns, and double slash to move to the second line. So these 3 columns are 4 columns are here and 3 rows are here, and this array can be made easily. Now moving to the next one. Yes, how to put this? Now you can see that this is an array or matrix with the slash left ordinary bracket, slash right ordinary bracket here, and an array containing 3 columns. What is the first column? First column has the first element, this determinant, and this is the second row, and this is the third row. Now I can type that in a single line. So let us assume that this is just X for a moment. So I will type $. Okay. So I need a left bracket and right bracket. Okay. So slash left. So this is an ordinary bracket. So after some time I need to close the right bracket. Okay, so I have prepared with this left and right bracket. Now I need an array with the 3 rows and 1 column. So an array is started having only 1 column, which is center aligned, and let it be some X, Y, and Z. So you can see that this is just a matrix having X, Y, Z in one single column having elements X, Y, Z. Now you need a determinant here. So if I run this, I can see the output as, okay. So I need to replace this X with an array like this. So I need a left vertical line, right vertical line, and an array which is of order 2 by 2, right? It is UVWX. So instead of this X, I can directly write out it is slash left vertical line, okay, let me put some enders to some space here and slash right vertical line. Now I need an array. So array, it is 2 by 2. So I can put CC since there are 2 columns. Then I need X, Y, Z, W. So X or UVWX, U and V in the first line. Is it right? Yes. And W and X in the second column. Now I have completed this expression. Okay. So this is how such expressions can be obtained. Now to go to another problem. Now this should be clear. I'm not going to spend too much time for this. So this is a fraction. This can be obtained using fraction command. For the first fraction, you need a fraction in which the numerator is x plus y by 2. Okay, and the denominator is 1 plus y by z plus 1. So now in the denominator, when 1 plus is there, after 1 plus, you need one more fractional command, right? So this is the output of that command. So you have a fraction, and this is the numerator, and this is the denominator, as I told you. So there is a numerator and denominator, you can see. Now in the denominator, after this 1 plus, we need one more fraction command whose numerator is y. Okay, please check it with the corresponding expression, and denominator is z plus 1. Right. So such expressions are. Now how to handle multiple lines? Now this is simple. You can identify this as an equation array. Okay, you can identify this as an equation array because in order to have an expression like this, you can put y in the first column. Okay, and there is no element in the second row. Sorry, and is equal to as the second column, and this expression in the third column. Now this is for the first row. Now for the second row, you can see that in the first column nothing is there, so you can put some blank, and put blank in the second column also, and in the third column you can put I plus J plus K, etc. So in one single step I can show you the answer. Now similarly, how to do this? This is also you can identify with an expression. For example, y in the first column, this in the middle column, and this as the third column. You can see that an equation array can handle exactly 3 columns. It assumes that your expression has 3 columns, and you just need to place your expression to the corresponding columns. Now if I show you the corresponding command, okay, so this is an equation array. Star is here. Why? Because there is, I don't need a equation numbering for this expression. So y and is equal to and this means that in the first line I need y in the first column. So this and changes the column. So is equal to in the second column, and changes to your expression to the third column. So you have a plus c plus etc. and so on. Now here you can see that when you have too many elements, you can put L dots. So that is also used here. So the second problem is again an equation array having only one line. Okay, and y is in the first column. Now this slash LL gives you this type of symbol, and a plus b plus, then L dots is placed here, and plus a. Okay, so this is the corresponding command. It doesn't matter whether you write everything in between begin equation array and end equation array, or everything in a single line, or maybe in 120 lines. It doesn't matter. You will get the same expression because this is a programming language. Okay, you just need to care that only need to care that after one command, if another command is not following, you need a space. For example, here slash begin up to this is a command. then this y is not a command, so you need a space. Okay, and this /ll is another command. However, and is also a command because it is the command used to separate the columns, so you don't need a space. But after and you need a command, you need a space because this a is not a command. So in between commands you don't need a space. In between a command and a text or math expression you need a space. Okay, so in whatever be the way you write this, you will get the same output. Now let us check another multi-line thing. Here also you can see that you can arrange this with an equation array, because you can treat this in the first column, this only equation in the second column, and this in the third column for the first row, and for the second row you don't need any element in the second row first column and second row middle column, and you just need some expression in the second row third column. So how to do that? Okay, just need equation array. Now what is the specialty with this? So you can see that you can not do in one single step using equation array. So you need an is equal to sign somewhere, and you need to start from somewhere but not from the starting. So you can see that /left equation command can be used at this stage. So I will only provide you the required command. So this is equation array /left equation of y1 plus y2 plus y3 plus y4 is equal to. Now this tells the LaTeX that this is some expression that is having 0 width. Okay, so even though it is there, LaTeX considers that it has a 0 width. Okay, now you can go to your next line and put just double ands, so that only a small space is spent for the first and second columns. I will show you with the precise command. Okay, so it is equation array /left equation. Now this is the first equation, /left equation is there. Now in the second line you can put 2 ands so that there is no space spent for both columns, and in the third column you can put some a plus b plus. Okay, now this is how you can bring your expressions in the second column without leaving too much space for the first and second columns, even if the first line contains, or the equation array contains a column having some large width. Okay, so this left equation converts this to something which is having 0 dimension. Now let us move to another problem quickly. Moving to another problem. Yes, now this is not difficult. This is just overbrace and underbrace, or these are just overline and underline. So this overline command brings an overline to whatever be the expression you put in the argument. For example, here you just need to look here. So this overline, this is overline of this entire expression. So what is this? This is some z square plus 1, but for this z itself there is another overline. Okay, so this overline when it is started puts everything or puts an overline over whatever be inside the argument. Now the second overline is only for the z, so you can see that some z bar square plus 1 bar can be put using overline. Similarly, this underline, you can use underline both in text mode and also in math mode. So you just need to put /underline and the expression which you need, and for which you need an underline and or math expression. Okay, now what is this? This is an underbrace and this is overbrace. Now remember that you can put suffix and cap. Okay, superscript for this underbrace and lower underbrace and overbrace. For example, let me type a to z. So it is slash, as a new line, it is a plus b plus c. Sorry, I don't need c. So it is some c dots plus y plus z. So this is just a plus b plus etc plus y plus z. I am going to tell that all these this a to z contains 26 letters. So I am going to write slash underbrace in curly brackets a to z. Also, I am going to say that b plus 2y contains 24 letters. So I need an overbrace there. So it is after b and before this plus z, I am going to put an overbrace. So it is slash overbrace, curly bracket is started and closed after y. Now if I just to show you the output, you can see that only underbrace and overbrace are placed. Now I need to say that these are 26 letters, these are 24 letters. So I can put an underscore here after this underbrace and a cap here after this overbrace. So here after this I can put underscore. Since there are more than one letter, I will put a bracket. So it is 26. You can also put 26 letters. Now after this overbrace, I can put cap 24. But since there are more than one letter, you can put a curly bracket. Now let us move to another problem. I'm going a little fast, but you can see the same thing in YouTube video when in the ASAP channel, ASAP Kerala. You can do many other things, etc. Using. Is it possible to see this part? So this command, this thing can be obtained using a white hat option, and this command, so this is not this cannot be obtained using a slash frc command, because slash frc centralizes whatever be the content given to it. So here you need an arrow mark in the middle and f dash in the top of it. So you can use stack rel commands. Now this expression is placed on the left hand and this expression is placed on the right hand. So you can do that with an hfill command. So once again, if I show you the commands, so this wild hat 1 minus x gives you this expression is equal to slash wild hat minus y. So that gives you expression. In order to put everything to the right hand side, or left, put the entire sentence to left aligned and right aligned, you can put horizontal fill. So this is hfill. So this hfill takes everything to puts everything in that sentence to left and right ends. Now this what is the specialty of this I plus j plus k? So you can see that there are no dots for this I and j. If I put a dot over I, you can see that since there are one more expression arrow mark or one more tilde appearing here, it will may look like complicated. So there is I math symbol. This I math symbol brings you an I without a dot. Similarly, j math symbol command brings you a j without a dot. So this is the vector command for the I, and tilde command for the j, and hat command for the k. You can see that here. Now the stack rel command, I already told you, in order to put something over something, other than using the fraction command, you can use the stack rel command. I just need to show you only the stack rel command. So only look at this expression. So here a stack rel has two arguments. One is f dash and the second is right arrow. So this shows that f dash can be placed on right arrow, where this right arrow is positioned in the center of your expression. Okay. Similarly, all these types of expression can be made. Now, before going to another AMS math and AMS tools, math tools, sorry, AMS math, math tools, AMS theorem, bibliography, and beamer. So I need to show you one more slide. I have made all these resources available in our college website, 𝐾𝐽 college website, under my profile. You can check it later. Okay. And in the next class, you can see some of the tricks used to draw these figures. All these expressions can be made using AMS math package. So I have put it in my website. You can see that. So here you can see that on your left side the corresponding expression, and right side the corresponding output is placed. So you can see that all these types, or I can say that everything is possible using this AMS math package. So these are a lot of commands or a lot of expressions, different types of expressions. Everything you can make using AMS math commands package. So if there are any questions, you can ask.
Sir, question is, how can we caption a matrix?
Caption. Usually a caption is appear in a figure or table arrangement. So you can either insert the content of a matrix as a table, but you need to put math expressions or dollar symbols at each step. Okay, at each of the elements in a table, and then you can put a caption like that. So that is one trick. Or you can bring a matrix or convert a matrix to a figure using some other screen capturing or some other devices are there, and you can put a matrix as a figure and put a figure caption. Now usually we don't put a caption for a matrix. That is why usual techniques are not there. We put a name for a matrix, but we don't usually put a caption.
Okay, fine, sir. The next question is, where double dollar is used?
Double dollar is used when you need to display an expression. Okay, so when a single dollar is used, you can see that when you are writing, for example, consider a function f of x is equal to x square plus y square. You can use single dollar, so that this math formula becomes inline. That is, you can see, and just after that you can see f is equal to x square plus y square. When double dollar is placed, LaTeX puts that entire expression centralized and with enough display style, that it is another style, and with sufficient large expressions. Means it has some display style option also. So when double dollar is there, it is docked from that inline and moved to another line, centralized and with a display style option. So that is what a display style option or double dollar. You can also put the slash square bracket in order to put a display style.
Okay, sir. Will you be able to explain the expression for summation once again quickly?
Yeah. A summation need, so I will show you a slide. So you can see that all these types of symbols are available in LaTeX. Okay. So in order to put a sum, you just need to put slash sum. Okay. So slash sum brings you the summation symbol. Now in order to put summation from 1 to n, so this 1 to n actually appear below the sum symbol, and n appears on the top of the sum. But in order to put that I is equal to 0 to n like that, you just need to put underscore. So whatever be the symbol you have, the underscore, the expression after the underscore brings that expression under the symbol. Also, whatever be the expression comes after this cap. Okay, if a cap is there, whatever the expression coming after cap, it is placed over the summation symbol. Okay, so not only summation symbol, all the symbols. And you can see the corresponding command. I have placed it in the starting. Okay. Yeah, so you can see that the sum brings you the summation symbol, and whatever be after that underscore brings you that expression under the summation symbol, and whatever comes after cap, you can see that n is only after cap, so n is placed over the summation symbol. Okay.
So thank you so much for again joining with us, and we believe we will be joining again for future sessions also. Dear participants, thank you for your active participation.